Hello, everybody. It is 6:52 p.m. Central Time on the 8th of October, 2020. We are here on the Earthquake 3D live stream, of course, if you don't know where you're at. And you can see me here on the screen, just a rare appearance, just to show that I'm a real person. Some people on YouTube said they thought I was AI. Well, I'm not, unfortunately, at least not yet. Let's go ahead and get me out of here, though. Let's get a display capture turned on so you can see what I see. We are using Earthquake 3D, the program. If you don't know what it is, there's a free version and a paid version. And the free version gives you access to one feed at a time. The paid version allows you to combine feeds. So we're combining the USGS and EMSC coming out of Europe. So we get a good broad swath of the earthquakes. And we're looking at about 48 hours worth of activity. We can look at the whole week on this feed here, these two different combined feeds. And we're just looking at 48 hours. The reason we look at 48 hours is it gives us a good idea of the areas that are moving recently, which then helps us to determine the areas that are next yet to move. And yesterday, we had a series of deep earthquakes that took place down here below the plate, right here where we have a letter D. Letter D stands for deep earthquakes. It's a spot where we watch for new deep earthquakes to occur. And a deep earthquake raised high off the globe. Again, that's something if you don't know what you're looking at. The higher these are off the planet, the deeper they are into the Earth. And these are down below the plate in an area what I would call down below the plate in the asthenosphere. The asthenosphere is just a complex term to describe the magma down below the plate that's semi-melted. And here's what I think is going on. I think that down below the plate in the magma, there's concentric waves coming across the curvature of the underside of the plate, and they combine into a central point called a singularity or spike. And that singularity or spike then hammers up in from the fluid up into the hard underside of the plate. And you can imagine over a huge distance of thousands of miles as an accumulating wave points up to a center point. And as we know, fluids can't compress much. From that hammer point, I think what's happening next is something like this, what's called a standing wave. Now, a standing wave, this is in a tank in water, but same thing could happen through the plates themselves with radio wave type waves, VLF. Now, that's natural, of course, in the ground, but so these waves spread out, and as they spread out, they become, instead of jostling around and getting chaotic, they organize and form into what's called a standing wave. And the standing wave, you'll notice that the peaks of each wave form into a valley in between each wave, of course, and they fill in each other's middle fulcrum point, that middle point between the waves. One wave fills in the next open zone perfectly in the middle. I can park my mouse, for instance, right over it, and you'll just see wave after wave spread and move. Now, then, to top it all off, these waves can actually move through a tank, for instance. So let me show you an example here at the end of this video, that these waves, these standing waves, don't just stay in a spot. They will move, if in the right angle or at the right angle, they will move, in this case, through a fluid, but you'll notice that the wave isn't losing much energy as it travels down a huge distance. Now, they'll show it here at the end of the video reflecting off a wall and coming back. Watch this. So it comes down and reflects off the wall and comes back perfectly without losing hardly any energy. Now, guess what? If you launch another wave into that, the waves will reflect off each other. And then that takes us back to this, which as the waves are spreading across the tank, for instance, they're filling in each other's middle points. How does this play into earthquakes? Well, let me take you back over here. Hammering in on the underside of the plate, we have a deep earthquake. Then spreading out and away from the push, we have same-sized earthquakes, just like the waves in the tank that I just showed you, where each wave was the same size. And in this case, we have 4.9, 5.0. 4.9, 5.0. And then on this side, we have 4.9, 4.9, 4.9, 5.0. And then on the edge, we have a 4.7. And up here, we have 4.7 and 4.9. Or no, two 4.9s. A lot of 4.9s, right? Well, think of those 4.9s just like the tops of those waves that I was just showing you. But in the middle, where the waves combine, that's where we get our larger earthquake coming up from our deep earthquake. So again, hammering action down below, spreading out through the wave tank. And in this case, the wave tank is the plate boundary. Let me show it to you. It's a giant red line here marked on the USGS map here. So hammering action on this side, spreading out across the quote-unquote wave tank, dropping off the same sized earthquakes all the way along the way, spreading up all the way towards Japan and out all the way to Indonesia compared to the earthquakes in the last 48 hours. Again, like I said, 4.9, 4.9, 4.9, 4.9, 4.7 on the edge, and all the way up here, 4.6s. So again, as the wave spreads out, it might lose just a little bit of energy, and that's exactly what's happening. But as it comes back, that's where we get our central fulcrum point, those waves as they sort themselves out. So we come back up in the center between our other deep earthquakes, which I don't know if you're going to see them here. Let's see if we even have any still reported. Well, the USGS is going behind or just not reporting it. There was a set of deep earthquakes that happened here earlier today in the Forest Range, the Europeans reported, and USGS, I guess, ignored that deep earthquake activity. But just imagine a set of deep earthquakes there, too, where this is the middle point. And 2 days ago, we issued the warning for new large earthquake activity to strike right here. I had warned right here, which is called the Solomon Islands Solomon Sea. And the new earthquake struck right next to it. That's definitely an earthquake forecast hit. I'd like to point out this 6.3 came in at 6.7 originally. And then they downgraded the earthquake to 6.3. And that's not my take on it. We all watched them downgrade it from 6.7 to 6.5 to 6.4 to 6.3. I'm going to go see how they came to their determination, though. Oh, wait. No station details contributed to this determination. Wow. Well, let's go look at the body magnitude, see what those show, all the stations. So the stations, this is the low-end way of measuring. This is the body magnitude. Okay? There's a difference. Local magnitude, I don't even know if they have local stations. That's probably why they're measuring it this way. But going down the list, we would throw out the extreme high end, and we would throw out the extreme low end. But on the body magnitude, I call this their low ball list, if you will. That's a good way to refer to it. The low ball list, we go down the low ball list and see where it is. And I'm seeing 6.5s as the highest on the body wave magnitude. Body magnitude. And just keep going. I mean, there's a lot, guys. Wow. Okay. Here, I mean, the highest on the list so far is 6.6 and 6.7. And like I said, we throw out the high end and we throw out the low end, which will throw out the 5.9s and 6.0s. So it's somewhere between 6 and 6.4 or 6.5. What's the difference? Not much. They have it at 6.3. They originally, like I said, had it at 6.7. So they downgraded it, whatever. It's still a larger earthquake. Let me get at this point here. This deep 6 struck 2 days ago. When this deep 6 struck, let me get everything else out of there. We warned the area here at Solomon Islands for a shallower, larger earthquake to strike within the next several days. And now a shallower, larger earthquake struck. And not only that, each middle point was filled in, spreading out across the whole area in the past day and a half. So like that standing wave that I showed you in the tank, it spread all the way over to Indonesia with equal distance spaced earthquakes. 4.9, 4.9, and then on the very edge it starts to diffuse out just a little bit. Now before we go any further, I have one more thing to show you. The 4.9 spread up here to Japan, but not just anywhere. It struck at the volcano that just erupted, Kakai Caldera, which is interesting because Kakai Caldera hadn't erupted since 2004. Right? It's been so long since that volcano erupted. I have to go check the Volcanic Ash Advisory Center now, just to see if there's anything going on. So let's go down the list. And let me make sure you can see the list. Shivalush. Okay, Shivalush is up in Kamchatka, Russia. Sanjay at Ecuador. Ibu in Indonesia. That's back. That's finally back. It's been gone for about a week and a half, 2 weeks. Fuego in Guatemala. Ducono in Indonesia. Sanjay in Ecuador. Reventador in Ecuador. Sabancaya in Peru. Popocatépetl in Mexico. Kluchevskoy back up in Kamchatka. Shivalush back up in Kamchatka. Fuego, Sanjay, Reventador, Sabancaya. We can repeat all of the volcanoes I just named several times and then add in Kadovar. Now, just a quick story on Kadovar. About 2 years ago, we issued the reason I'm mentioning Kadovar, let's just stop right here. Let me show you where Kadovar is. Kadovar is right here, right in the middle of the arrow, and it's right next to where our big earthquake just struck. We'll go back 2 years, and I issued a warning for an upper 7 to strike here. There was a big, deep 6, a huge, I think it was like 6.8 or 6.9 earthquake, struck down below the plate here, which prompted me to issue a warning like I always would at the middle point between the quakes, but it was for an upper 7. So we're waiting through the week, and I think 3 or 4 days into the 7 to 10 day watch, instead of an earthquake striking there, this volcano, which I will go show you over here on Google Earth, called Katovar, had not erupted in 1,000 years. And suddenly, it blew with not just a small blast, it was something like a 35,000 foot high blast. And let me see if we can find it. Let's see. Katovar volcano, where is it? Well, you know what? Here it is. Next to Bam Bam and Blup Blup. Yes, those are real names marked by the Smithsonian. There's Blup Blup, named by the locals, and Bam. But Katovar had not erupted in 1,000 years. This is old imagery of the volcano. This is what it used to look like. Now, I guess they're going to have to do another flyover to get another shot of this thing. It'll be interesting to see what it looks like when they update the imagery. So 1,000 years, and then suddenly, boom, with like a huge blast. And the mainstream media even weighed in on it and said, the first unexpected blast of the year, like that's something normal. And we took that. No big earthquake struck there. Instead, that happened. So I took that as the big earthquake. I would count that as an earthquake forecast hit, obviously. So same thing has happened now. A new deep 6 happened over here 2 days ago. And then now a shallower, larger earthquake came hammering up. And then a spread of the same sized earthquakes going out across. But over here in Indonesia, guess what? No eruptive activity across South and Central Indonesia. For instance, no eruptions at Mount Sinabung, no eruptions at Semeru and Kerinci. Oh, and Krakatau. No eruptions all the way over. We have to get into here. We're right in the middle of the whole hot mess of seismic activity, where all the rings overlap. That's where Ibu and Dukono both are. Once we go to the north, like I said, 4.9s, but notice something about these. They're two of the same exact sized earthquakes, right? And then you see this 4.6 up here to the north. Let me show this to you on the plate boundary map. It'll make a lot more sense. Okay, so USGS doesn't have all the earthquakes on here, obviously. Their feed is, I don't even know what it's doing, but 4.9 here and 4.9 here on both sides. And a 4.6 up here, right north of where this letter H-shaped bend in the plate boundary is. So energy has come up on both sides of this, and I've forecast for this so many times in the past. As a matter of fact, it's just a regular thing we look for if you're a regular in the chat room, for instance. If you see an earthquake strike on this side, you watch on this side for something similar in size and proportionally spaced. Remember the waves in the tank, equal distantly spaced, standing waves as they travel through the tank. And then at the end of the tank, we might get a little bit of loss of energy, going down just a little bit, but then that means there's going to be a reflect back point. Just like in all the others, our halfway point. And our halfway point, the fulcrum point, comes in then back here at the middle point, back here at Philippines, going up into Taiwan, and here at Guam, the tiny island of Guam. Both are going to get hit by something larger than what's on both sides, because you've got to remember this is going to come back, and in the middle is that fulcrum point that's sorted out. And a bigger earthquake strikes in the middle, the fulcrum point, between the current waves. And going back to the USGS map now, energy coming up on both sides this way, and so far it's reached here, but the tank doesn't end there. That's just an interference point, obviously. Up to the north, it carries on, up, over, and into Alaska, as well as it goes out over towards Europe, following the plate boundary, all the way out to the Azores. See the red line? And let's go over here to my map. We have arrows going across Asia in the last 48 hours, but you'll notice there's a big open silent zone here where there's no earthquake activity or volcanic activity. Northwest Sumatra, Indonesia, going up to Smith Island, Myanmar, Laos, Thailand, Cambodia, this middle point right here. Now, we look along the red line where the arrow is. USGS even has the plate boundary map there. We look right through here. The middle point, but middle point between what? Middle point between these earthquakes here. Imagine the wave tank again, where we've got a set of waves going on over here, equal distantly spaced, by the way, and same size. I'll get into that in a second. And we have equal distant spaced waves here, but they're much bigger. It's like a bigger rock in the pond has been thrown in on this side, and on this side, we do have a disturbance. In the middle where they meet, that's again the spot where we watch for a large earthquake. So it's not like just one spot. So something larger than what's on all sides here is going to strike here at Philippines, something fairly similar in size is going to strike at Guam, and a new large earthquake should strike at the middle point, larger, I should say, than what's on both sides right now. So if we have 5s on one side, 4.9s, and we have a set of mid-range 4s on the other, then we would look for new 5 or greater activity. And I want you to have a 1 magnitude larger plan just in case I'm wrong, in case I'm undershooting this. Or let's just, what if they undershot the reporting on the quakes? What if they're all 5-point-something range earthquakes? That's more likely than them all being 4.9s. But I mean, look how many 4.9s there are. 4.9, 4.9, 4.9. This is in 48 hours now. This is USGS now. All different quakes within the last 48 hours. And I've got all the earthquakes 4.0 and greater turned on. So 4.9, 4.9, 4.9, 4.9. Then a 4.8 here, and a 4.8 here. And then look, 4.9 and 4.9. And then back here, what's in between the 5s? Oh, another 4.9 and another 4.9. And then on the edge, a 4.8. Sound familiar? It's the same size wave spreading out across the tank, whether they're 4.9s or 5s. Now, if they're all 5s, it just looks more sinister, like on Mother Nature's part, right? I think that's why the USGS downgrades each earthquake to 4.9. It's happened so much, we're making t-shirts for this, for the 4.9 Society, the secret 4.9 Society. It's also $4.99 become a Twitch member. Maybe I'm in it. Okay, so middle point's going to get hit here at the fulcrum point, and then look at this. The same sized earthquake spreading out in 48 hours across Myanmar, West China, or northwest of Nepal, right up here at the Afghanistan border with Russia, or Tajikistan now, and then over to the west, a 4.2 to the east of the Caspian Sea at the Iran border. So look at it this way, equal distance spaced quakes, same size wave going across the area. That means this middle point here, this middle point here, and this middle point here should all be filled in by something larger than what's on both sides of each middle point. So for instance, let's just go into right here. So eastern Nepal, China, Bangladesh, but mainly right here where the rings overlap. We have to watch for something bigger than what's on both sides, 4.4 and 4.6. Add them together, it equals something like a 4.8. But I would look for, let's just put it at a 5. Same with right here. We would watch where the rings overlap in North India for the same size. And one more time, over here to the west. So we have 3 sets of 5s that should be incoming here. This is in between Iran and Afghanistan. Then, over to the west, let's take a step down to 3.0 range because we can then see the EMSC reported quakes. And all you're going to... Oh, a new earthquake has struck here at the Aegean Sea in green, but we'll wait for that in a second here. So we, again, have the same thing going on that I've been talking about around the rest of the planet. The equal distance spacing on quakes. You can see it. It goes over here to Iran, stops at the Caspian Sea. Again, look at all our 4s. It goes and stops. This is, by the way, if you don't know where the Caspian Sea is, this is the Caspian Sea here. This is Iran to the south. But it doesn't stop there. It just takes a step down slightly into the 3 range. At the Caspian Sea, it spreads out across the plate boundary in mid to upper 3s. Actually, let me get all the 2s out of there. Here is our 3 and greater. And so you see a 3.7 in the middle of the arrow, you see a 3.5 in eastern Turkey, and then you see the same sized activity, 3.4, striking here at the Aegean Sea, going down to Crete. And maybe I should turn the rings down. There. So looking at the rings there, you see them all marked in white, all these 3s. But let me take you back over to the USGS map now. So I just showed you equal distance spaced 4s going across the plate boundary on the inside of it, or the north side of it, across China, and then dead ending here in the Caspian Sea, where the USGS has the plate boundary to the south, right? But going back to my map, look what we have. This has been on here for years, the arrow to the north. The reason we have the arrow to the north, I have to show it to you visually because the USGS has nothing on there. Here is Iran, here. Here is Afghanistan, here is Pakistan. Zooming in on it, you should be able to even see it with the naked eye just from flyover here, that this looks like a flowing river, doesn't it? But these are mountains. These are folds in the plate. Each one is a mountain itself. It looks like flowing molasses over a long period of time because it is. That the stone is moving over a long period of time under compression, severe compression. Now in the middle, again like a river almost, This is breaking on both sides. Now the USGS has a plate boundary marked along the south edge, which goes down here to this number 7 bend in the plate called the Carlsberg Ridge, here on their map. But on my map, we have the arrow to the north because the plate is bent that way. That's the Craton edge on the interior. So like a flowing river coming out of the Himalayan range, breaks across and bends across, indicating that force is flowing across the area, bending the plate boundary on both sides. And this is more stubborn block of its own separate plate that's blocking the flow around it. So when energy is deposited into the plate boundary on the red line, it flows over and around, path of least resistance. Hence the earthquake up next to the Caspian Sea, the 4 something, which is the same size that's coming out of here, right? Now look over to the west. 4.6 right here on our arrow, but not just anywhere. It's where Greece meets into Albania on the east side of Italy. And the magnitude is, well, there's 2, 4.6 and 4.2. We're going to add them together. And this is a separate report of the 4.5. Again, it's just 2 agencies reporting here. So 4.6 and 4.2, if you add them together, equals 4.72. Why does that matter? Well, let's go back over here and add these all together, these 4s here. 4.2 plus 4.1 equals 4.31. 4.31 plus 4.4 is 4.47. 4.47 plus 4.6 is 4.5, well, let's just round it up to a 4.8 worth of energy if you add these 4s together. Each 4 you add on, you just add on into the decimal point zone, guys. So why does it matter? Because that's the energy that came in. A 4.6 plus a 4.2 equals 4.72. 4.8 put into the system. 4.72 comes out of the system down at the tail end where it doesn't stop. It breaks even further, like a flowing river, like I just showed you in Iran, going around the edge of the plate. Over into Europe, it goes around the edge of the plate. And let me show it to you on the USGS map now. Here. So it comes out from here, breaks around Iran in 2 directions, pulls back up in eastern Turkey, goes back down and around the W-shaped bend, and dead ends right where I showed you. East of Italy, right in the plate. But notice, USGS doesn't have anything marked. Somebody said fuzzy math. Haha. I'll explain it again. I've explained it before. Basically, let me do a simple one for you. Let's do a simple one. This is a 4, and this is a 4. Drop the points entirely. Just imagine them. They're both as 4.0s. 4.0 plus 4.0 equals 4.2. 4.0 plus 4.0 plus 4.0 equals 4.3. 4.0 plus 4.0 plus 4.0 plus 4.0 equals 4.4. Every 4 you add on takes it up a point. So you get up by a full magnitude. If you have 10 4s in one area, guess what it equals? A 5. If you have 10 5s in an area, that equals a 6. The way I add the magnitudes for computing for finding the middle point. It's fairly simple. Now it gets a little more complex when you start getting into the hairs of a point, like 4.4 plus 4.6 or whatever. Like 10 3s equals a 4. 10 2s equals a 3. 10 1s equals a 2. 10 7s equals an 8. Do you understand it now? It's fairly simple? Okay, cool. All right. And again, I had to invent that on my own. That's something I had to invent on my own for adding magnitude. And it works. Okay, so energy was put into the system. It added up to 4.8. Went across just like that standing wave thing that I showed you. Let me show it to you again. Because this applies to the United States too. So first it hammers in on the underside of the plate, spreads out following all those red lines I've been showing you on the USGS map. Then, as it spreads out, imagine each one of these as an earthquake dropping off along the way. As more energy is pumped in, guess what? The wave gets bigger. The waves combine. Let's get a close-up on that. The waves get bigger, the amplitude increases, and the earthquakes become bigger. But they all stay relatively in the same size as they spread out from the disturbance that originally pushed it to begin with. So the standing wave is then spreading through the tank until it meets a resistance point, where it then reflects back. And at the reflection back point, we get back to the middle fulcrum point. that's filled in. Each wave top fills in the middle point. And the middle point, I think, is the highest point, whether it's the highest or lowest point or somewhere along the way, along the slope. That's where the earthquakes of the same size strike. So strikes across same size distance all the way over to Europe, dead ends into Europe at like the end of the tank. But look, we have the arrows where the USGS map has nothing. The reason we have the arrows there, let me take you over to Google Earth. Remember I just showed you here on the actual visible satellite imagery on Iran, it looks like a flowing plate. Well, the plate looks like a flowing river. It pulls back up over here in Turkey, and I just mentioned Europe, how the USGS doesn't have anything marked across the plate. Instead, they just have the plate boundary coming up from the south here, across Crete, going up and dead ending here into Italy. They also have the plate boundary. Let's go show it to you again. See their red lines? Notice anything missing across Europe? How about nothing? Well, they don't mark the craton interiors, but look, you can see it in the mountain range itself. It looks like a backwards S shape or a serpent or something, right? But this comes around and down and goes into Bulgaria. And getting back to my arrow map, that's why we have the arrows there. Because this seismic force, the wave, as it goes through the tank, path of least resistance takes place. It'll go around something as opposed to brute force through it. So when you introduce this wave into the plate, it then goes around the plate, or tries to, and drops off the same sized earthquakes all the way around the edge of the plate, like it's a guide in a tank or something. Now here, across North Europe, you see these bulges and bends in the plate. Here, 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 going over. At every fold along the plate, let me turn my place marks back on. Get a load of this. This is in Europe now. Same thing in the United States. Where do you see this? In the United States. It's just United States is flipped sideways, basically. Here, we have volcanoes at every fold in the plate. Where it makes a bend here, volcanic field marked by the Smithsonian. Here, volcanic field marked by the Smithsonian. We go up around, and in Central Europe, look, at the fold in the plate, 2 marked volcanic fields. Here, here, here. And then we go over to Western Europe. And look, they carry on. And look, they're equal distantly spaced. Nobody's noticed this. The professionals missed the equal distance spacing on the volcanic fields. I wonder why they're equal distance spaced. Because Mother Nature sorts out this force in a standing wave. So like I said, the force can come into the center of the plate. And when it hits in hard enough, it can go across the plate from the center. And when that happens, we then can go consult the USGS map. If enough force comes in from down here, it'll hammer up into the edge of the plate up between Turin and Milan in North Italy in the South Swiss Alps. Now you understand why the Swiss Alps are rising up here. Because the plate boundary force is exerted up through Italy, up into South Europe. Now so far, the energy has come into this point, right here, on the back east side of Italy or the south central point of Europe. So far, it's in the mid-range to upper 4 range. That's pretty big. New activity should, new activity should spread over to Romania, which technically it already is. But we should see something much larger over to Romania, at least 2 magnitudes larger. So like 4, upper 4 should be coming into Romania. And unfortunately, this also means up on the plate boundary in North Italy. And looking at the smaller earthquakes in Italy, I actually have to warn everybody from Turin and Milan all the way down to Norcia again. But this time I think it's going to be up near Florence, and I think it'll be about the same size that's going to strike in Romania, and about the same size that already struck right here. I mean, the amount of energy, the wave that's been put into the system is in the upper 4-ish range. It's going to spread out across Europe in 2 directions, one over to the east, the other, obviously, up into Italy. And then it won't stop there. English Channel should get hit. Up here at North France, a coast of Normandy. Oui? And it should only be in the upper 3 to low 4 range. But that's still pretty big for up here. So watch out for it. English Channel, South UK. I mean, don't fault me, no pun intended, if it comes in South UK instead of the coast of Normandy. But I'm looking for the English Channel, coast of Normandy. Then, to top it all off, the spot we warned, you can check it off the list, the North Pole, or at least the Arctic Circle. Now, I warned the North Pole, but here on the arrow in the Arctic Circle, we got a new 5 that came rolling in right on the arrow. I don't know if that's all she wrote. I still think it's going to come all the way in up here on the north side, and follow our arrows up to the north. The push was big enough this past week. Let me show it to you. You can see it here. Last several days, look out here to the west. Bunch of mid-range 5 activity. X marks the spot was hit directly on it at the Azores with a 5, as well as a swarm breaking out here, which you don't see. USGS totally ignored that swarm that hit in Iceland directly in the middle of the X. But look, this is this past week. 2 here, 2 here. X marks the spot. I mean, actually, you can say 3. You just, guys, USGS ignored it. What was it? Like 4.5, 4.4, 4.3, 4.2, a bunch of 3s, all hit here in the middle of the X as well, where the rings overlap. So really, it's 3 sets. But you see 2 there, and then look. X marks the spot just got hit this morning down here at the southeast tip. Now, the southeast tip brings me nicely into the next part of this update. So let's go over to the USGS map again. Right? We can jump from Europe out to the mid-Atlantic ridge, where I just showed you the activity that spread to Iceland and up to the North Pole next to our X's to the north. But backing it out, we're going to go back down here to the Pacific. Here's the Pacific as most people normally see it. So United States, South America, Australia over to the west. And we come down here to the southeast tip of the Pacific. We have a USGS fallacy going on here. This is them, guys. Let me get a sip of my drink now. Okay, we'll wait. So energy comes across the entire plate and spreads down to the very southeast tip. Now let's go over here and see where the earthquakes are. And you'll see they match. They go down to the southeast tip where we have the letter X. And that's right where the earthquake struck. But we can trace that back because the other set of X's was hit just a few days ago. Here on our fracture zone, that fracture zone goes right back up. You see it goes to the northwest. It connects with the underside of the plate where all those, well, I guess undersea mounts, I was going to call them volcanoes, but they're undersea mounts, which are undersea volcanoes. They go back up in a line and connect to where our deep earthquake came hammering in. Remember what I told you about the wave one more time. As the wave spreads out, equal-sized waves spreading out in all directions from our hammering point on the underside of the plate, this concentric wave that comes hammering in. So as the force spreads out, it drops off these earthquakes along the way, and it went down following this like a waveguide itself, dropped off the earthquake, 5.2. Why does that matter? Because the rest of the energy, 5.2, ended up down here at the tail end of the tank that I just showed you. So it went all the way across, following to the south. And you can connect this from over here, down across, over across, down and over, and down this way. You have to back it out to see it, though. Now, looking at South America, everything I told you about the rest of the planet, about the equal distance spaced earthquakes, spreading out across an area. Now, look where our 2 sets of arrows point, these 2 large sets of arrows. The reason I have arrows there is because of the equal distant spaced fracture zones. This is Leviathan for a little pun, I guess, made by Animatronic, my good animation maker. But, okay, so the equal distance spaced fracture zones that are out here, they go all the way up to the North Pole. But you'll see they come over here to the west and they pretty much dead end into all these undersea mounts that make a chain, which if we back it out, you might be able to see this in full resolution if you're watching in HD. It goes all the way down and makes a crescent shape down here to the south. And we can follow that over to the east, and it goes and then makes a C shape or a crescent shape up into South Peru. So let's follow that back from Peru here, back across, back up where the undersea mounts really take form. Then we go across and we meet up with the Hawaiian Island chain. But look, it carries on. It goes all the way up to Kamchatka where our other deep earthquake is. There's a connection, and it goes down across all of this from up at Kamchatka. Let me try to get it so you can see it again. From Kamchatka down, branches off to Hawaii where it dead ends out in the middle of one of these equal distance spaced fracture zones. Equal distant. I keep saying that, but that's what it is. It's not equidistant because that's perfect spacing. I would say they're equal distanced apart. That's a better way of saying it. I know that annoys some people, but we'll add that into my new terminology, a new word that we had to create for this. But you know what I'm saying, that they are equally spaced everywhere east of this undersea mount chain. Everywhere west of it, look, we have thousands of volcanoes and undersea mountains and islands that have formed, where all the hammering action comes in on the underside of the plate. Let's go back over to the USGS map, where all the hammering action comes in from here over to here and up to here to Japan. Force coming in on the underside of this. And then where the fracture is, apparently, some kind of mini mid-Atlantic ridge, let's call it the mid-Pacific ridge, everywhere east of it is these equal spaced fracture zones. Why, though? Forces distributing out equally from this point, obviously, which means there's a leverage action coming in from all the way from here to here, and it's pushing out across and spreading out across this way. Now, right here where the C-shaped bend ends, you see we have an arrow in between what looks like an open passage that goes back up here and meets out to the very far northwest. Do you see that? So it crescents up here, and then here we come down and meet into a fracture zone. Let's go over and show you on the USGS map. Now they have it marked. The fracture zone's here between the plates, but there's a connection point. We leverage in under here. We come across in two directions. Two directions go from up here to up to the north part of, go from Fiji up to the north part of South America, and go from Fiji all the way down to South Chile, like a giant letter V out here. And then look where the arrows are. They too point in the same directions. When leverage action comes in on the underside of the plate here, or when the wave comes in and spreads out, it divides almost equally to the north and to the south. It then hits the end of the tank again, like I've been talking about in the rest of the update. To the north where it hits the tank, it has a way out and around over to the north where the two X's are. Let me show you the way that the wave takes out to the north. Power coming across, hits into here, goes up, follows the wave guide over to the east, along the plate boundaries, going over into Central America and over into the Caribbean, where it dead ends out at the eastern side. Now, wait a second. Haven't we seen that shape before? It's just a little smaller. And down here to the south, we have a bigger one. And up here, now, here, let me show it to you this way. It's a little bit, you'll remember it a little bit better. But you know what? You'll remember it that way forever now, right? Okay. Now, here, let's go and look at the Earth sideways. It's always fun to learn here on the Dutch Sense channel, isn't it? Okay, now we're looking at Earth in a way you would never normally look at it. But look at South America this way. Now it looks like flowing molasses going around the edge of the plate to the north and to the south. Remember that flowing molasses analogy because we talked about that over in Iran with the plate bending coming out and flowing coming out of the Himalayan range and coming off of the Andean range, or the Southern Rockies, if you will, that the Andes, and it curls out again like flowing molasses. I'm going to turn back on my volcano place marks, and we'll go down here to the south. Check this out. Let's just get this on. There we are. Okay, hopefully we can see this. If it populates. Again, I've got so many place marks on. Okay, here we are. Here are the Smithsonian marked volcanoes. Now, this is the South Sandwich Islands. Let me turn this back north so we can get proper orientation again, just in case you've never looked at the Earth that way. On this edge, this flows out and across. This is about 20,000 feet higher than this. So we can move our mouse over and see the elevation. So here, we're at negative 10,000 feet. So starting at sea level, we go down 10,000 feet. Pretty deep ocean, right? Now here, we drop off. And we go down to 22,000 feet deep. So it's like a ledge. But more, it looks from this distance, it looks more like a landslide. Like a flow over. Where the Pacific plate is flowing over the Atlantic plate, the South Atlantic. And that's this. And it really is a drop-off of like 10,000 foot all the way around it. As this is clearly part of the Pacific plate. But it's pushed between. It's flowed in between over a long period of time by this seismic force. Now, guess what's right in the middle of this? In the middle of it, we have a fracture zone that comes in. USGS doesn't have it marked, but you can see it here. It makes a zigzag shape and goes over to the east. So look what's out at the front end of this. A line of volcanoes, right? Now let's go down and look at the earthquakes. Right at the very tip where the flow over point is, where the volcanoes are, a new earthquake right where our letter X is. That's why we have an X there. So I want you to remember the shape, though, and the way the volcanoes are spaced. Do you see that? Do you see how the volcanoes are spaced there? That's Mother Nature now. They're just marked by the Smithsonian, too, but you can see it. They're equally spaced again, or almost equally. But look, let's go all the way up to the north, and we're going into the Eastern Caribbean, and look what we've got. We've got the same thing, but more volcanoes, but again, they're somewhat equally spaced in clusters. 1, 2, 3, 4. And let me turn it sideways again, where you can clearly see that it's flowing over. Just like the point that I showed you down here in far South America, here, where it's a 20,000 foot drop off, and this is flowing over, same thing. Here. This is about a 20,000 foot drop off. 19, 20, 21, 19, anywhere in the 20,000 foot range. But this is flowing over, and right on the flow over point, that's where all the volcanoes are. They're taking the same shape, too, the same crescent shape, and turning this back north. We can then compare to the USGS plate boundary map. Look. So energy comes across as these waves traveling through the tank, the Mother Nature's tank, the red lines. As the waves are going through the tank, they drop off the same sized quakes. To the north, it does the same thing that I just talked about to the south. Clearly, this time to the south, it was bigger. There were 5s to the south. And this time to the north, there were 4s and a 5 to the north. But it's nonetheless the same. Look, looking at 48 hours or 72 hours worth of earthquakes, we have the same sized earthquakes. This is showing us everything 1.8 and greater. So same size quakes forming a V shape that focuses in here at Colombia. And you see we have these small red arrows here telling us which way to watch for the energy to go. And where one ring overlaps the other, going right over to the east. Let's get the smaller quakes out of there and look at it again. There. Do you see it? Maybe I need to back it out. And then compare to this. Coming in this way. And look, the USGS has nothing there. That's why I have these little red arrows telling us when energy is coming across this, when that wave is traveling up through the red line and it spreads out equally, it goes right across here. Boom, 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 and dead ends over here. Next stop, our X's should get hit. Either in between them or directly on them. And I mean in between, like middle point. Either the middle point between the X's or one of the X's should get hit. 5.3 came rolling in here over on the eastern edge of Puerto Rico. That's the U.S. Virgin Islands. And that's a 4 back behind it over in Eastern Dominican Republic. Look where the rings overlap. They overlap where we're swarming. There's a big earthquake swarm going on now here at Puerto Rico again. And I say again because previously you guys have gone somewhat down in the number of quakes, but the number of quakes now goes up off the screen to the point where my Puerto Rican viewers are writing me. Well, guys, look, again, one more time. You are the overlap point between a 5 and a set of 4s. Let me get the 5 and 4s. See where the rings, whoops, there. And you already had a 4 in the middle at Puerto Rico, there. So do you see where the rings overlap? That's where the swarm point is. And it's just a sign that the eastern edge of the Caribbean plate has been inundated with power. We can go back over to the west, and a series of volcanoes have popped off here across Central America, across Popocatépetl, going down right to here. I mentioned the volcano already when we looked at the list. That's Fuego volcano, right here where the red lines come together. It's no coincidence that Fuego's back erupting right now. And to top it all off, a new earthquake did just strike just south in the 4-ish range. This 4.5 just struck in the past couple hours right where the two come together. Volcano erupting, new earthquake strikes there. This whole thing is charged. I would look between the two. I would look between the earthquakes now along the coast of Central America and the big cluster outbreak here across Eastern Caribbean, which then puts Cayman Island, Jamaica, Cuba, right here in the middle. Now, let me show you. There's something there. See this stair step? That's like a block point. We've seen so many earthquakes strike right next to this. When there's a big push coming across, and there's already something going on here, remember the wave principle again, that the wave comes reflecting back on itself. Let me see if I can get that on the video here. That the wave will come back on itself, and the wave can reflect off other waves. And when they combine, they form a standing wave. And when they form a standing wave, you can get a hammering action where equal distance space quakes, or something bigger than what's on both sides when it's reflected back. So I would watch the middle point for something bigger than a 5, because we have 5 over to the east and 4s on the west. That would be something bigger to strike in the middle in the next few days. Now, each of these middle points is also going to get hit across Central and South America. We're about to go through the roof across the rest of the planet, and I've already showed you 3/4 of it. Let's get into the United States. So a new deep earthquake striking up here on our letter D next to Kamchatka, where Shiveluch volcano is erupting, and also Kluchevskoy is erupting, and a new deep earthquake one more time with this hammering action that comes in on the underside of the plate with these deep quakes, that there's hammering action coming in up here in the northwest edge of the Pacific plate. To top it all off, let me get it on the USGS map. Not only are we hammering in here and here, we are also hammering in up below this edge. And when that happens, energy, just like I've told you in the rest of the planet, spreads out equally across over into Alaska and then over into the North American Craton. And once it gets into North American Craton, that starts to affect us in the United States, and everybody gets concerned. But this is how it gets to us. I'm going through the full Opus update again, so every person new can understand how this gets to us. United States usually gets to us last. And the push that's come in this past time, we went through a big, deep earthquake event around the planet where multiple earthquakes struck, and we didn't get much, but then it finally came in. Now, looking across from where our deep earthquake came hammering in, going back to the USGS map, see this red line? The earthquakes come in, go up into Alaska, and meet into the edge of the deformed portion of the Craton, up in the far Pacific Northwest. That then charges North America, or Laurentia. North America is called the Laurentian Plate, but let's just call it North America. Charges North America up with seismic energy, which then comes down into what's the most famous seismic zone I think everybody knows about, the Juan de Fuca fracture zone with its jagged sawtooth edges that point into the Pacific Northwest United States. And see how smooth this is, the plate boundary, as it comes into the broken, jostled edges, or more like a sawtooth, cutting into North America. And think of this three-dimensionally now, that this is down below, and this is up above. Or like a bathtub is another good analogy, that this is the bottom of the bathtub, this is the side top of the bathtub, and we get energy that comes in from underneath, and it goes up into the plate. When there's a big push that comes in from up here, or from over here, when it comes into the northwest, it then displaces the rest of the North American Craton, down through California, across the rest of the United States. And so I'd like to bring you over and show you this from a different angle. Looking at 48 hours, or this is 72 hours, but looking at 48 hours worth of earthquakes across the United States, you again can see a large diagonal line of quakes going from the Juan de Fuca that I just told you about. It's this lightning bolt-shaped fracture zone up here. And look at the magnitude range on these. Here's our 3.0 and greater earthquakes. I'll get 2.9s out of there. There we go. 3.0. Notice anything about the quakes? Well, certainly across central and southern California and up to the north, equal distance spaced again. 3.4, 3.1, 3.2. 3.4, 3.4, 3.5. Think of this like a wave coming in across the plate, and then it takes a slight step down once it goes over to the edge of the plate. But then it follows the edge of the Craton, like I told you with the rest of the other plates that are flowing like molasses. They look like they're flowing like molasses. Let's go look at the United States. And let me turn off all of my place marks so you can see this. Make sure you guys can see it. There's the Craton edge. Compare to this. Look at North America coming out of the northwest here, going down across Idaho, going right through Yellowstone. This is Yellowstone National Park and Lake Yellowstone. Then going down across through Colorado, then going down through Texas, and it makes a bend up to the north. This looks like a river, doesn't it? That's a 1,000-foot bulge in the plate. This is 1,000 feet higher than this. Goes up and makes a bend up into Arkansas, where it then makes a bend into the New Madrid seismic zone. Then makes a U-shaped bend down through Mississippi and Alabama, up to the east, all the way up the east coast. It matches the edge of the Craton the folds in the plate, but you can hardly see it because of the trees and erosion and time frame that we're talking in. But seismic force flows in from up here down across the edge of the craton in two directions. Let's get back to the quakes now. Looking at the quakes, you can see it. The earthquakes, all the same size, started swarming out, going down the deformed edge of the craton, the purple part of this diagram, right up to the more stable portion. And in the last 48 hours, the same size quake spread out like the wave tank around the edge of the plate, all the way up to the east. And we're going to get into each set of these quakes because this is important. What I'm showing you, this is breaking cutting-edge geophysics that no other professional ever saw or heard before. And I hate to be the one to do this on social media, of all things. How immodest of me to do it publicly, live. But here, hold on, let me get a sip of my drink. Today we're drinking orange juice, guys. So we're doing okay. So remember what I told you about the equal distance spaced threes across the West Coast? Because once we get over to the Midwest and the edge of the craton, it takes a step down to twos, but it's the same thing going on in clusters. Equal distance spaced quakes. Look where they all overlap. Well, this is Yellowstone National Park. At the surface, we have the magma chamber coming up to the surface of Yellowstone. But what would you do if I told you that the actual magma chamber for Yellowstone is 11 Grand Canyons in size and spreads over down below central Idaho and goes as a feeder for it all the way down below central and north Oregon? And coming in from the northwest of Oregon, a feeder for it, the center of the magma chamber, the 11 Grand Canyon size, is actually, again, right below where all these earthquakes are happening, up above it in Idaho, where fires have broken out. Now, the earthquakes are equal distantly spaced, whatever, across the entire area, like a giant ring around the magma chamber itself. This is in 48 hours. That's a new development that we haven't seen in the past few months, at least. This has happened before when a big push comes in from the northwest. Now, before I get into anything more, I want to show you the hot spots that we've been keeping track of now that an earthquake swarm broke out on the New Madrid seismic zone as a result of the hotspot releases and the plate shifting in the Midwest. Let me show you something going on in the Northwest. It's not only happening again here in the Midwest. I'm going to show it to you really quick in the Midwest. We got cloud cover over us for the most part, so it's going to be a little hard to see in South Missouri, but looking at our shortwave infrared really quick, and again, let me just make sure you can see this. We're going to look here in southern Missouri, right here in the boot heel tip, and you will see them throughout the day today. It's going on again today. And they're flaring off across Arkansas and southern Missouri, still on the New Madrid seismic zone, but then the clouds overtake our view. Kind of hard to see. We'll go back down to the south, and maybe we can see a little bit in Arkansas a little bit better, but it's a little hard to see with the cloud coverage today. But it's still going on. That's my point. So as it's carrying on, that means energy has not fully flowed out, but we're going to talk about some others. Yeah, you can see it here right about there. But again, it's really obscure. You'd have to know what you're looking at to even see it. They're little black dots up here. See these three black dots? That's just three of probably hundreds, if not thousands, that are flaring off underneath all that. So it's still carrying on, but where and what? What is carrying on? Here. This is the New Madrid seismic zone. This is the Mississippi River Valley. This is Arkansas. This is Mississippi and Alabama. This is St. Louis, Missouri. And let me just turn on my borders and labels so you can confirm that. I know my geography pretty well by memorization at this point. But anyway, the New Madrid seismic zone makes this N-shaped bend in the plate, and then it makes a U-shaped bend down through Alabama and Mississippi. Now, all of this, starting at the town around New Madrid itself, New Madrid, Missouri. People are saying, is it New Madrid? No, it's New Madrid. Starting right down here, there's the town of New Madrid, all the way over into the woods, so we know it's not farmers burning their fields, and going down to the south by southwest, again, in the woods, across the river valley mainly, all these thousands of hotspots just across here. Each one going for 5 minutes, which we know can't be a fire because no way a fire is going to go out in 5 minutes. And secondly, it's only right here, as that is the middle fold point in the New Madrid seismic zone. Now, going over to the west, we have these mountains that you can see here. They're somewhat bent and twisted, and you can see they match with the edge of the craton in Arkansas and that bend right before the New Madrid. Something happened here in Arkansas. Right here, a few weeks ago at Fort Smith, a natural gas pipeline broke apart. A big explosion happened there. Another natural gas pipeline broke over here in Oklahoma City at the fold in the plate that goes down across into Texas. The U-shaped bend on the edge of the Craton. So energy goes across the Craton, goes down through Texas. And look, earthquake struck at the drill points in Texas, and there are tens of thousands of drill points in Texas. Now, I'm not going to show them to you yet. We're still talking about the hot spots. But along the edge of the Craton is what I have to first show you, so you will understand where we are with the hot spots here. So hot spots here. Edge of the Craton goes back down and around, back down through Texas, goes back through New Mexico, back up through Colorado, back up through Wyoming, back up through Idaho and Montana. And as it goes back up to the northwest, oh, look what our earthquakes do. The earthquakes go back up to the west by northwest. And I have to talk about this because 2 earthquakes struck in western Colorado. But this is just, we can't overlook what I'm about to show you. I'm going to pull the bigger of the 2, but they're right next to each other. Which one do we want to pull? We can pull either. They're the same size, 1.4, 1.5. Paonia, Colorado. Now remember what I just told you about the natural gas pipeline exploding in Little Rock, right? Within the same 48-hour time period of the natural gas pipeline blowing in Fort Smith, which is south on the Craton, west on the Craton at a town called Dotsero, a natural gas pipeline blew. And it caused a massive blast, and people, I think, got injured in the blast. So where is Dotsero in relation to this new earthquake? Look. Just wait for this to populate. See this? Dotsero volcano. It's one of the only marked Smithsonian volcanoes in Colorado. It's right off of Highway 70. It has its own exit off the highway. And the town that blew was Gypsum. This subdivision right here at the tail end of Gypsum, right next to the school. And there's the volcano. So in the same day, basically, or 48 hours, we get a blow-up explosion at Dotsero volcano here. We get a blow-up explosion down here at the tip of Texas. We get a blow-up explosion here at Oklahoma. And we get a blow-up explosion here at Fort Smith, Arkansas. That was just a few weeks ago, all in 48-hour time period. And that was all along the western and southern edge of the North American Craton going into the Midwest. That was the shifting that was coming in, again, a few weeks ago. Now we have 2 new earthquakes right there. Now let's go pull the 1.5. This should put us right at Dotsero itself, or right next to it. Colorado's volcano is getting hit, right in the middle of the edge of the Craton. We cannot ignore this anymore. If you're a professional, you cannot ignore this. Dotsero, the volcanoes are all getting hit. Yeah, look where we are. We're at Basalt Mountain, Carbondale. We're a matter of like 10 miles from one of the only marked volcanoes in Colorado. Again, from the Smithsonian with the red triangles. Now we have fires further up to the north on the edge of the Craton. If we're again looking at Colorado, where the edge of the Craton goes and really bisects or cuts in half Colorado, look where the fires are. They're right along it, right up here on the north side, on both sides. Dempsey Dome, that's burning. Bull Mountain Volcanic Buttes, Delaney Volcanic Butte, all burning right next to each other. That's northern Colorado. The hot spots. Now, I have to keep talking about the hot spots because up here, we already talked about the cluster of earthquakes around Yellowstone's magma chamber. Well, up here in the Pacific Northwest, that's where this all goes back to. Let's tie this whole thing together now. Are you ready? You guys ready? Hey, wake up, everybody. Come on, man. That's ridiculous. Wake up. You in the back. What's your name? Ninja. Something ninja. Wake up. Okay. Young Padawan. Okay, here's how it all ties together. Coming in from the northwest, the energy comes in, like I explained, all the way around the rest of the planet. That standing wave comes rolling in, and then it inundates the Juan de Fuca fracture zone, where these sawtooth edges are basically cutting into the United States. Something happens here at the Juan de Fuca when the energy comes in. It doesn't just transfer into the United States without being noticed. Let's go over and take a look at what we call the tremor map. Now, these are tremors. Tremors are not to be confused with earthquakes. Tremors are small vibrations as something moves. For instance, we see tremors at Yellowstone, hundreds if not thousands of tremors per day as the magma shifts down below, and there can be a magnitude assigned to it, but it's not like fracturing up above it in the crust. There's no breaking of the plate or crustal faulting or anything going on, just vibrating. And over here on the West Coast, you see all these red dots. There's 510 of them as of yesterday, all across the state of Washington and down here at the southwest tip of Oregon. Now remember the Juan de Fuca that I've been showing you throughout this update. Here, the sawtooth edges. These sawtooth edges belong to the Pacific Plate, which obviously the Pacific Plate's in motion. There's waves traveling across it, right on our doorstep. This is where it comes in, up the doorstep. Remember, it comes in and up the plate. Comes in from here, goes up into the plate here. And the energy is obviously coming in from the northwest. We can go see. That's where all the tremors are. The northern edge of the Juan de Fuca coming in and up, and like an arrow pointing into it. Right here, these three jagged sawtooth edges pointing right into Washington, where we started shifting all the way down here to South Washington at the Oregon border. Going back to the plate boundary map and the tectonic tremor map. Here. So all across the Puget Sound going down to Washington-Oregon border region. Now, southwest Oregon right here, this is Northern California. This is southwest Oregon. And maybe I need to turn on our topographic and street map again. See, there's Medford, Oregon. Now, do you see this out here to the west? It's like another arrow. The southern arm of it with its sawtooth edge pointing right into where we're shifting right now. So we're shifting up here, and we're shifting down here, looking on the USGS map. Looking on the PNSN map, you can see the tremors, hundreds and hundreds of them as of yesterday. Let's go back a day. There were actually a little bit more, 538. But notice anything. It was up north. Up north, there was a little shimmying and shaking and vibrating up in Vancouver Island. Now, wait a second. We move forward a day to yesterday, and it shifts to the south. Think of this like a teetering scale right now. One day it's on one side with a few dozen on one side of the hundreds, and then you move the next day, and it's shifting down to the south. But wait a second, what's teetering? Think of this like a two-arm scale. This is the center, and it's up here to the north it shifts, and down here to the south it shifts. That's why it's not perfectly equal shifting. It's shifting where these points are, which means this is where the charge is coming in. And then it goes in on the edge of the craton, and it tries to spread out across the plate, which then goes across the plate like I've been showing you on the plate boundary maps and the topography map here on Google Earth even shows it. Oh, wait. Again, my place mark. There's so many place marks I have to turn them off for you to even see anything. Going across North America, following the craton edge. Going down through Texas, back up into the New Madrid seismic zone, which is swarming, hot spotting, all the way down the fold in the plate, the weak sedimentary fold points, releasing heat, which is causing fires, I guess. It's also happening on the West Coast. Let's get into the West Coast. So a spread of quakes going down to Yellowstone, coming out of the Northwest. Look at the earthquakes in the last 2 days across the Pacific Northwest. You want to talk about an increase in the number of quakes, especially today. Let's go turn on the last 24 hours worth of earthquakes here. So this is 1 day, 0.0 and greater from the good old USGS. And this will remove a few. They're going to see a few pop off. Technically, they're more than 48 hours old or 24 hours old. But it doesn't do much. You can still see the spread of quakes going all the way over to the East Coast. So remember what I told you about the equal distance spacing of the quakes. All those threes going down through California, going over to the edge of the craton. But the East Coast has started to move. Pennsylvania. Hey, how about that mine collapse now? Changing that over to a mine collapse. Well, whether it's a mine collapse in Pennsylvania 2.9 or whatever you want to call it, a series of other earthquakes have now broken out, and it's on the edge of the craton. So whether a mine collapses in Pennsylvania following the hotspots, or whether it's a break in the edge of the craton over to the east, look at the East Coast. Look at this. up here in Pennsylvania. Look at the bends and the folds of the plate of the craton. I mean, so, again, is it a mine collapse or is it just energy transferring out? Because we just had a swarm on the new Madrid seismic zone. And then, same time, a mine collapses up here in Pennsylvania. But they changed it to a mine collapse, but then guess what they can't keep doing? They can't make them all mine collapses. Other earthquakes started to strike. Right around the other spot that just had its earthquake. So it's like God's trying to get a message to us or something. Let's go into South Webster, Ohio, and see what's there. Inquiring minds want to know about a rare Ohio earthquake. But look at Ohio on the edge of the craton. You won't think it's too weird. But there are things, I think, here nearby that we might need to look into. I don't know how close we're going to find them. But from what I recall, there are a few spots in Ohio that have drilled for oil and gas to do what's called fracking. And we should be able to spot any fracking operations if they're out here in the woods, or we find people's houses, of course, but we should be able to find them if you guys know of any that are nearby. And I know what to look for. We look for tanks and pumps and jacks and pipelines. If I don't see any nearby, I start to get a little suspicious about the earthquake, focusing in on Ohio, of all places, Minford, Ohio, and Wheelersburg. I remember those names from something. What do we got going on in here? More houses. I just seem to recall that name. And you know what? As soon as I break off out of here, somebody's going to send me info and tell me that I'm just missing the pumping operations nearby. You know what? There's a way to search. There's a way to search. I think they have an interactive map that'll give us the info. So let's go search it. This is how you do it, guys. So I know I'm live, but I know it's going to be a little boring, but Minford, Ohio. Fracking. Let's see if that brings it up. Ah, there we go. Fracking in Ohio map. Let's see. Whoa. Whoa. Dang. Bookmark this. All right. Let's bookmark that and use it. Where is Minford again? Okay, boy, that is right down in South Ohio, right here north of the river, right in the first county at the center line. Okay, this should be pretty interesting. Dang, guys. That is... I mean, I don't even need to go... I don't even need to go find the actual well. Do I? Oh, man, I should have done this. I shouldn't do this live because it will take a minute. I wish I could type in the town. Well, let's see if I can. No, that's just a search. Well, it's going to take a minute to actually find the town through all the drill points, which apparently there's enough drill points here. Let me just click on one to get some info. Yeah. Okay, each one is viable. Look at the name of here, Gassville. Okay, that seals the deal. Gassville and all these wells nearby. I will try to find the actual pumping operation, but that's gonna be a little time consuming to try and get in there and see it. That's enough right there, though, wouldn't you say? Now, up here in North Carolina, or right at the border with Virginia, there's still the outbreak that's taking place on the edge of the Craton one more time, but that's from the big outbreak from the 5 that hit there a few months ago. The Craton is blocked, clearly still blocked right across this region from Pennsylvania, not really flowing too much up here to Vermont, New Hampshire, Maine, southeast Quebec, but a lot of hot spots went up there. Now, West Coasters, listen up. Mount Rainier volcano, Mount St. Helens volcano. I already showed you that you're shifting and tremoring up here on the tremor map. Here, today, yesterday and today. Hundreds, you're slow slipping. The plate is, quote unquote, slow slipping from the Juan de Fuca up into North America. But there's a spread of quakes going to your volcanoes. Just like Yellowstone. The magma chamber for Yellowstone is being slightly perturbed on the edge of the craton as energy's coming in from the northwest. This is going to be leading to a large earthquake, I think. Do you think we can displace the whole United States with hot spots and threes across the whole plate and fires breaking out and God knows what else that we're not hearing about when it comes to pipelines breaking and buildings collapsing that can happen when the plate starts to shift? Now, I would think that we would get a big quake in the middle of the area, and I'm watching the New Madrid seismic zone because of the hot spots that are still going on there and going back up to the northwest, up to Idaho, where all three sets of rings, get this all ties together, guys. All three sets of rings here in the last 24 hours overlap on a point that I've been focused on for 2 days. And the reason I've been focused on this area, let me show it to you one more time. We'll go to the sub-regional sector, go into the Pacific Northwest, looking at shortwave infrared to show us our hotspots and our fires, and we're going to click at Washington. We're going to look here at the border with Idaho and Washington and Oregon, where there's been a series of hotspots that have showed up as little black dots or black signatures here on the map. Let me fast forward it and see if there are any today. This is now today, live. Yeah, oh yeah. Now, I don't know if you'll see these. Let me just bring it back and forth. They're flickering on and off. Each one's 5 minutes long. But they're detected at 500, 800 degrees Fahrenheit. And they're quickly gone. Quick as they're there, they're gone. Burst of heat coming from the edge of the craton. Okay. Now, let's get back over, and people are telling me the craton or the tremor map just updated. Let's update the tremor map. Yes. Okay. The tremor map has just updated within the past few minutes with today's tremors from the 8th. So let's recap on the tremors. The tremors, as of yesterday, were doing this. A cluster in Washington and a cluster in southwest Oregon. Today, the tremors have gone and shifted and grown. They've grown in 2 directions. Well, both spots have grown in 2 directions. The tremors to the north in Washington have extended in an arm, reaching now down to the Oregon border, right at the river. The Columbia River, I think that's the name of it, isn't it? I don't know the name of it. Yeah. Oh, I got it right. Yeah. Columbia River. Okay, so it goes down to the Columbia, but that's reached all the way from the Puget Sound and Tacoma, all the way down into Oregon. So that's reached to the south. Then, the other cluster from the day before, let's compare. Here we are on the 7th. Right, in Medford. Here we are on the 8th. It's spread to the south and spread to the north. So the southern arm of the Juan de Fuca energy is coming in and saturating the plate here. The plate is shifting, vibrating, moving. And the spot in between, from, let's say, Portland all the way down to Roseburg, Eugene, Salem in the middle, high and dry. No seismic activity, no tremors, no vibrating, no shaking. Do we have any earthquakes? No earthquakes. I would say out here where the tension's coming in, somewhere between here and where it's shifting to the south, we would look to that middle point for the release. And I would look out in the ocean before I would look on land, because the breakout in the ocean is where the plate boundary is, going back to the USGS plate boundary map. This is all happening in real time. So the plate is shifting now with 566 more. Washington, Oregon, California is not moving much, at least not with the vibrating, and Vancouver Island is not moving much. That means most of the energy is coming in from this central point and going in. If it goes in, it's got to go somewhere. So with the plate shifting here, we now have to put everybody on high alert down in California, of all places, on top of watching over where I am for the New Madrid seismic zone. We also have to warn on California's coast let's now go in and see where we have to warn. So, shifting up here in the northwest, 9 times out of 10, if I were to put a number on it, results in shifting down in central and southern California. The more we shift up here and vibrate, the more it goes into the edge of the craton and tries to go across. Also, it saturates down along the coast, following the plate boundary. One more time, let's go over here, following this, following the red line. Where a new earthquake just struck, actually. Hold on, new 2.5 just struck at Pinnacles. You see the thick red line as it goes down to the south. That's the San Andreas. So the San Andreas literally flows off of the Juan de Fuca, which is shifting and charging right now, seen with all the tremors on the map for today. So all this is vibrating and shifting. Energy is coming in from out in the ocean. It focuses in on the edge of the craton, tries to go across it, hence the earthquakes in Colorado and Texas, shifting in, hot spots in Missouri and shifting in hot spots all the way up in Idaho at the tension points, where there's a lot of tension coming in on the plate, obviously releasing heat. But it also goes down across California, following the plate boundaries and the most interior faults along the California-Nevada border. The more energy, when it shifts up here, we see it go right down across the border from Nevada, going all the way down to Ridgecrest in Southern California. It shifts up here, you move down here. And like I said, the more it shifts up here, the more you move down here. But it's not the same. So you're vibrating and shifting up here, tension's put into the plate, power's put into plate. But here it's where it breaks. That's where we get the breaks that come off of the push that goes over to the edge of the craton, which is more stable, allowing it to flow around like a river going around a large stone. West Coast, though, it goes right down the plate boundary. This thick red line is a fracture in the plate, guys. The San Andreas, most people don't think of it this way, that starting at the surface is where the fracture begins, but the red line that we've talked about, the whole update, goes around the whole planet. This is a fracture that starts at the surface and goes all the way to the underside of the plate, where the heat and magma is. So it's not just a break in the plate. A fault is a break somewhere in those miles of rock. But this is a plate boundary, a thick red line where there really is a break from the surface all the way down below to down below. So when that wave reaches into the United States, it reaches the Juan de Fuca, hammers in, starts to vibrate up to the north, all the tremors, and then down to the south, the earthquakes come rolling in. And we're looking most likely now at 5.0 plus activity to come rolling in. Now we can determine the areas to watch. There should be at least 2 different events that take place. One event associated with the northern arm of this, where, here, let me get back over to the USGS map. This, the northern arm of the San Andreas, going into the Hayward Fault, should be something up here, centered in between our current sets of quakes. So that would put us on the north side, I would think, on the north side of geysers, and on the south side or near Eureka, we would look for a 5-ish to come rolling in. Second spot is the obvious spot. Here, Bay Area, but I would put it just a step below 5. Let's put it at upper 4. Both earthquakes should strike there, 2 separate events in the next few days, as related to the northern arm. Then we should have 2 separate events down to the central and south. Central point is a little tough for me on this. I'm leaning towards the overlap point here between Monte Cristo Hills and Long Valley Caldera. Let me show it to you on Google Earth, but we're talking about the same size. So I'm thinking in the 5 range. So I guess really that's 4 5s, right? But it's 2 separate events is what I'm talking about. One on the northern arm, one on the central and southern arm. Let me show you where. A new outbreak of earthquakes has just developed in the past few hours here at the California-Nevada border, marked with a green earthquake and a bunch of 0s and 1s. Now, think of this like a rolling drum, rolling snare drum. The bass drum hasn't kicked in yet, but the amount of drum beats per second has gone up. We call that the frequency increase on earthquakes. So the frequency here, the number of beats per minute, if you will, has gone up here at the California side of the Nevada border. On the Nevada side of the border, there's a volcanic field too. So there's a super volcano where the frequency has just increased. If this was the drum, the snare drum just started rolling here at the super volcano. Long Valley Caldera, 1,000 cubic kilometers of melt down below. On the side of this, hot spots. Fires broke out this past week. On the east side of this, the other swarm of earthquakes, which is a line. Here, let me zoom in and show that to you. It's a diagonal line of quakes spanning about 20 miles. 4 months ago, a surface fissure fracture formed here 12 miles long, broke apart in the ground. 6.5 earthquake also accompanied that here at the Monte Cristo Hills Volcanic Center. And the line, or the surface fissure break, going in that rough direction that the earthquakes are still going. But the earthquakes themselves go down to the border right here in between the two. You see there's a little outbreak right at the border. Well, what's right at the border between Monte Cristo and the supervolcano to the southwest? Let's show you. This. In between here and here, the volcanic hills, which are the easternmost portion of the Mono Lake volcanic field. But the volcanic hills and buttes, well, there they are. They speak for themselves. They're black basalt, and they make up the western side of Monte Cristo, or eastern side of Mono Lake. In other words, there's a volcano there too. And a new earthquake just struck right in here as I'm talking. That freaks me out. So we're in the supervolcano. A new little swarm is breaking out there. I would look between these two sets of quakes. Now, the reason I said I'm hemming and hawing on that is we have to go between these two sets of quakes here in the Owens Valley, going down to Ridgecrest. So we're going to see the number of earthquakes increase. We're going to see the magnitudes go up from 2s up into the upper 4 to 5 range. That's a 100-fold increase in power. And that's just getting us down to Central California with 2 events here and down to the south. That puts us so close to Ridgecrest. I'll just warn everybody from Ridgecrest all the way up to Long Valley. Owens Valley, that should get hit twice. Now, over here along the coast, as if it wasn't all enough, I think a new earthquake just came rolling in here. Hold on. What's the time now? 0024 UTC and 0024 UTC. Within the past hour, a new little outbreak here on the southern arm of the San Andreas, right where this little quake is right here. Let's go further down to the south of that. See, here's Monterey Bay. We're to the east-southeast of Monterey Bay. That's the quake. So let's pull the coordinates on this at Pinnacles. Let's get the info. Central California. This is coming from the Europeans, but they get the info from the USGS. The only difference is a missing decimal point on the end. It's not as refined of coordinates from the Europeans. Whoops. Oh, yeah, and they include a semicolon, which you annoyingly have to remove whenever you look up anything on anything. Okay, here we are. Here's the earthquake epicenter. And you notice I have a few place marks right here. Well, I should have them on both sides because they're over here too, but you see where it says frac wells? Let's start at the furthest most point where it says frac wells, right here. So we've got rusted old tanks, pipelines, drill points, flare apparatus, in case there's overflaring that needs to be done. Got another set of wells here. We go across the field. I think we go across, go across the field. You got another set there. And that's just a set of 4 or 5 of them. And the frac wells carry on over here, where they're kind of nestled back into the back hills. We've got the black tanks and the pipelines, and they go back to flare points and pipeline drill points. Anyway, this is the San Andreas right here. And look, we have 2 new hot spots that have showed up since yesterday. These are fire signatures detected here along the San Andreas directly. Again, this is the San Andreas right here. So we have a series of earthquakes that comes down to right where we have some hot spots. Pretty interesting. Meanwhile, about the same distance apart, diagonally, but equal spaced, across over to the east, that's where we pick back up with the quakes that go back down to the Owens Valley, here, where this line of quakes begins. So let's go look up this line of quakes. Olancha, California. I think the number of earthquakes down in Ridgecrest will increase, along with the magnitudes, like I said, upper 4, somewhere between Ridgecrest, going back up to Long Valley, as well as an earthquake between Long Valley and Monte Cristo Hills. As well as a potential of an earthquake over on the New Madrid seismic zone. I don't know how big because I don't have any other previous examples on hot spots flaring up in the thousands across the edge of a craton that hardly ever moves like this. It seems like there's a big earthquake coming also in the northwest, but I can't do a forecast like that yet until we see what happens with this current push and the shifting that's happening. One more time, the plate is shifting. The tremor map shows it. We have to wait and see what results from this on the push coming into California, which I think will be in the 5 range. So now let's go in and pull the coordinates for Olancha, California, and show you this line of earthquakes. One more time, a diagonal line of quakes. How many times are you going to hear that? Jeez. How did the professionals miss all these diagonal lines of quakes going across the plate, indicating that there's a flow and a force to the pushes that happen on a semi-daily basis? Oh, man. Paste these coordinates in. There we are. So we're next to Lee's Flats Volcanic Buttes, but there's something to the west. This. Red Hill, Golden Trout Creek, the topic of a discussion in my past 2 videos. This volcano, Templeton Mountain, and somebody corrected me on this. It's Monachi Mountain or something. Whatever. Monash Mountain is how it looks, how it's pronounced. So you can see there, Brown Mountain, it connects in a crescent shape. Hot spots appeared here with real fires on the western side of this giant oval shape that I talked about in my last update, which it's my premise. This is the remnant of an ancient caldera that's just lined with old volcanoes. It's just like the one to the north. This one. Long Valley Caldera, which is also lined with volcanoes, gets hit with earthquakes and hot spots and fires around it. Same with this thing. But now, a new line of earthquakes branches off over to the east of this, following the faults. The Owens Valley Fault, which are these thinner red lines that still make a diagonal line, and dead end down at Ridgecrest, where I expect an increase is certainly on its way. You can see it coming in now. It's coming in from the northwest, going down to the east-southeast. Let's get back to the USGS map one more time. Coming in from up here, coming in from up here. Both focusing in down here. Energy comes down the San Andreas, jumps over, following the drill points, over to the east by southeast, down here in the east-southeast portion of the valley, where Bakersfield is, for instance. Same time, that seismic energy comes right down these faults, and they all dead end and focus in right here. But in between there, the only good news for the people in Ridgecrest is that the supervolcano in Monte Cristo Hills is now forming basically a block or a barrier, hence the earthquakes going across it like a wall. And then look what branches off from there. That's no coincidence. This has been on there for 7 years. The arrow goes over to the east where our other earthquake is, down next to another volcanic field and geothermal drill point, down in southeast Utah. Do we even need to take the time to look up at 2? How about the nuclear test sites getting hit again out here in south central Nevada, Beatty, Nevada? I was just showing it to you yesterday. And these are man-made faults from blasting underground nuke test sites. Show it to you. Picture speaks 1,000 words. Here we go. And here's our valley of nuke test sites. Now we can turn on the Google Earth community, which has painstakingly researched all of these nukes, and get the info on each one or almost each one. So, U.S. nuke Operation R Memory. March 14th, 1979, 20 kilotons. Just one example. U.S. nuke Operation Knife B, as in boy, November 15th, 1968, 0 to 20 kilotons. So kilotons, that's 20 kilotons. They'll do thousands of kilotons, which is a megaton. Megaton blasts right up here. And they did them with the Europeans and the French. The UK, Europe came over and we all partnered together and did underground nuke tests there. And they blasted the whole valley. Every one of these is a different underground nuke test site. Man-made faulting is there. What about the lone earthquake down here in California? Out here in the Sandy Valley. They have it listed in Sandy Valley, Nevada. But look, guys, it's clearly on the California side of the border. Let's just go over to the USGS map. Hold on. Yeah. Look, it's on the California side of the border. They have closer towns to triangulate from. Why would they put the... What the heck? Let's go look it up. I haven't looked it up, so I don't know what's there. I do not know what's here. Really, I don't. So let's look. Looks like a river, old desert river there. Wait. Look at this. Hotspots next to a solar farm. We have a solar farm here. These are hotspots next to a solar farm. Now, the solar farm might show up as a hotspot unintended because of the reflection of the sun. But the earthquake, hold on. Is there more? No, wait. There are more hotspots down here in a river. Look at this. This is a river called ZZYZX. Look at this. ZZYZX. California. ZZX. California. Formerly Soda Springs, is an unincorporated community in San Bernardino County, California, within the boundaries of the Mojave National Preserve, managed by the National Park Service. What? There's hot spots in a river there next to a volcano. The Sima Cones and Volcanic Center. Right here. Sima Lava Field. We've got hot spots in the middle of the desert. Look at this. It is desert. It's like one of these desert river valleys. And that's all sand. That's not, this is vegetation here. These little specks. There's not even any vegetation there. Hold on, let's look it up. Okay. 6, California. It's real. It's a real place. Okay. All right. Moving on. Let me make sure you can hear me. Can you hear me? Can you hear me now? So, nuke test sites getting hit. Going down to the south, we get down to Southern California. And we have one more final diagonal line of earthquakes to talk about. Now, I've already told you there's going to be most likely 4 separate earthquakes. 2 up north, 2 central and south. Separately, those earthquakes, by the end of this week, maybe going into next week, 7 days from now, so today's date is the 8th, by the 15th, let's say, or sooner, that those 4 quakes, which should be in the upper 4 range, maybe 5, should add up into something more significant and strike down to the south. So, where do we watch? Just like all the other spots, we watch between our sets of earthquakes. This means the LA Basin, down here southeast of LA, next to San Diego. Let's go look at the fault zone map here. Here, the spot that just got hit with the 5 a couple weeks ago. Well, we have a new 5, something, that should come rolling in here down into the LA Basin east southeast. Everybody from North LA all the way down to the border, down to where this earthquake is down here in Baja. Well, we have to warn everybody from those 2 points, with the center point being right here in the middle on Anza Gap. Now, there's something about this spot right here. This line of quakes, or this line of faults. There's a line of quakes along it. Let's go show you. Here. Now, this is a semi-regular occurrence to go along this line of faults, but this is the San Andreas over to the east. You would expect the San Andreas normally to move, right? Well, path of least resistance, guys. Same thing that I've been telling you for the whole update. Path of least resistance. So it spreads out, but it goes from here to here, and the push has to be really big to come in and go around. Well, the push is going to be pretty big, and it's going to come down across, and it should focus in down here, where they all come together. Now, this spot, from here to here, 5 years ago. 5 years ago, an earthquake, a 5-point-something earthquake struck down here. And then thousands of small tremors started to take place across this thin red line. Now, wait a second. Up here, we got all these tremors going on, right? And they look like they're trying to connect between the two, and they are. Going along from Washington down into Oregon. At California, that's where the plate boundary comes rolling in, up here on the San Andreas, the thick red line. All this is shifting with tremors up here. Yellowstone is tremoring and shifting. And then down here, the professionals told us this was, shifting, tremoring, shifting, slow slipping is what the term they used, and with thousands of small tremors that happen here that don't get reported as earthquakes. So if it's shifting and tremoring here, and we have a diagonal line of quakes that goes from here at the Garlock back up to the supervolcano, jumps across, and picks back up on the San Andreas, goes back up to here, where we trail in like a flowing river, like this is the reservoir and this is what's flowing out, then the flood that would fill the reservoir is coming in. Hey, hold on. A new 3 has just struck down in Southern California. When did it strike? Hold on. It struck at 1:24 UTC. What time is it now? 1:27. 3 minutes ago. Oh my God. Oh, I need the Twilight Zone music. I really do. Okay, let's go look it up. There's our earthquake marked in red. So, again, this is right down where they come together. Now, this is the previous swarm point. It's where it broke before. There's something at the location. This is a perfect point to wrap it up with. Let me show you what's at the location down here in Southern California. Right where the two come together, where the San Jacinto comes into the San Andreas and the San Andreas comes into the Imperial Fault, where they kind of all meet together. We're going from the hot spots out here to volcano, by the way. Let's go down to Southern California. Beautiful Southern California. Look. There's our earthquake epicenter. And do you see anything here nearby? How about, how many fields away is that? 1, 2, 3, 4, 5, 6 fields away, 6 farmer fields away. We have a bunch of drill points and pipelines. But it's not for oil and gas. Those drill points and pipelines are taking steam back to these turbines to turn the turbines to provide electrical power for the area. So the turbines are for electrical power, and the steam is coming from the volcano here, Salton Buttes, which resides at the south side of Salton Sea. And so the new 3.0 earthquake is really just next to another weak point that's a volcano and a drill point, which has in common with pretty much everything else that I showed you throughout this update. Our drill points and volcanoes and craton edges are getting hit as power saturates the plate. And when it saturates the plate, it spreads out across the plate, trying to drop off the same-sized earthquakes along the way in a moving standing wave, which is called a soliton, by the way, if you're into technical terms. A solitary wave of translation is another way to put it. So you could look up solitary waves of translation. You could look up solitons. You could look up standing waves and concentric waves, singularity spikes, and combine them all, and you're going to get the earthquake effect that spreads out and drops off these equal-sized earthquakes across a huge distance, within a hair of a point of one another, and following the plate's boundaries and craton edges, as if it's following a waveguide or a tank itself. As opposed to brute force going through the center of the plate, it will go around it, this seismic energy. And when it goes around something, it drops off earthquakes along the way. If you inhibit the flow or block it, it builds up just like a flowing river and breaks free after a little bit and causes bigger activity. I think it's pretty obvious where we're built up and blocked, where it's shifting now, which we get back into the tremor map and the Pacific Northwest. Look, this is shifting here. A bunch of earthquakes going down across California, exciting at the volcanoes and going directly along the faults. We're going to be seeing 5.0 release. Going across the edge of the craton following the earthquakes, we go all the way over to the east and we get a bunch of hot spots and fires breaking out where we never normally see anything. Then we get a bunch of East Coast rare earthquakes right next to Ohio's pumping operations and down in the edge of the craton on the Virginia-North Carolina border region. All centered around where there's a swarm at the New Madrid seismic zone, which is just too freaky to ignore. I hope that's all she wrote with that. But the hot spots are carrying on, which indicates that the plate is still shifting. We would look somewhere between where the push is coming in and where the shift is ending. We look between those 2 points for a bigger release. And that, unfortunately, puts me all the way back over to the West Coast. And then the silent zone off the Northwest, separate issue entirely, the Juan de Fuca fracture zone. separate issue entirely out here in the ocean. But right now we're shifting on land, which means California, you're going to shift. You don't move here without moving down here. And you don't move here without moving over at Yellowstone or moving the edge of the Craton. So we're all due to get hit very soon. And you'll see it flow across the plate. It'll look like this, but way bigger. Right now we're dealing with zeros, ones, and twos with a couple threes. That will go up by a full magnitude. So where we're dealing with twos, we'll have threes. Where we're dealing with threes, we'll have fours. And you'll see it hopefully go all the way over to the East Coast. But West Coast is where it should be coming in now. New Madrid seismic zone, separate event too, which to me is just too many separate events. At some point, we have to tie them all together there and say, look, with this many separate large events going on, let's get back over to what the ultimate cause is here, which is fulfilled this morning with a new large earthquake striking in the middle of our open point in the West Pacific. Clearly, something is going on down below the Pacific plate, on both sides, north and south, west and east. When that happens, the plate starts to shift. When the plate starts to shift, we get big outbreaks. The bigger the outbreak, you can see it come your way. That's what all the arrows are on the map for. You can download a public version of that, by the way, the arrow map. Keep track for yourself. Free copy of Earthquake 3D is available, I know that. And you can get a paid version. It gives you more feeds and allows you to put the custom skins on the globe. But follow the arrows. That's what it's on here for. You will see it progress your way. And then once you understand that there's something coming your way, you can prepare for it. And you see something big coming your way, you know not to be shocked when something big rolls across your area. Then it's just a matter of determining which spot between our current sets of earthquakes is going to get hit. But that even is able to be determined. You look at your spots between your sets of earthquakes for your new earthquakes to strike. And of course, the more that start to strike, that gets us back into this, which is like the more waves that are in the tank, of course, there's going to be more peaks. And where there's more peaks or more valleys, that's where there's more quakes. So as you pump more energy into something, if it doesn't have anywhere to go, guess what? The amplitude increases. The power increases. The waves get higher and taller. And eventually, the waves will come out of the tank. Or if you're in an electrical system, it will form a standing wave in the electricity itself, and we will get a complete short out of the electrical circuit. Many analogies can be made on this, but I think most people can understand exactly what I'm talking about here. Okay, now, let's lighten things up. This was an ultimate long update, but I hope you got a good idea. The United States is about ready to move again. We're watching West Coast. We're watching New Madrid seismic zone. We want to see threes go up the East Coast of the United States and dissipate this energy with significant releases up in the Northeast United States. If it doesn't do that, then we're looking at a large earthquake developing in the Midwest to the West Coast, somewhere between the two. And then that nails us down on the edge of the Craton here, where obviously in the last 48 hours, we hardly ever see it in Colorado like that. Dotsero, come on. And East Coast, Ohio, Dotsero, Colorado, and Ohio, both moving on both sides of the Craton. It's a definitive line of quakes going back up to the Northwest, which we know is moving. The tremors show us it's moving. The volcanoes are getting hit, which Mount St. Helens and Mount Rainier. Yellowstone's getting hit. It's all coming in from the Northwest. The only thing missing is a significant sized earthquake out here in the Northwest, out in the ocean. That's the only thing that would fill it in, right? I mean, so that's all. Go over to the West Pacific. We can see where it's coming from. Do you guys have an earthquake plan? Do you know what to do when an earthquake strikes? You should take shelter. I've packed my car. Or my truck. Packed the truck. So I've got my stuff in there that I think I would need, because really, we're possibly looking at the threat of a large earthquake on the New Madrid, and I don't know what magnitude to put on it, because I don't have any previous examples on the New Madrid of hotspots or anything similar. So I don't know what to warn for, other than, well, if the plate's shifting, there's hotspots out the you-know-what, never seen it before, then an earthquake swarm breaks out there, then up to the east-northeast, the edge of the Craton starts shifting. Well, come on. So that would mean the New Madrid's loaded, and I'm not going to take any chances. So I loaded it up, and I'm waiting to see if anything happens off it other than a swarm. A swarm is all that it takes. That sealed the deal for me. But a large earthquake is still possible, I suppose. as long as the hot spots are going on. Man. And then to top it all off, we've got a hurricane coming in down on the coast, which we know low pressure systems, the piezoelectric discharge happening from crust to storm or storm insulated out in the ocean can actually have a discharge effect into the plate. And we can see a large earthquake develop below these low pressure systems as they come on shore. Happened over in Japan. We saw two hurricanes or cyclones come together here on the coast of Japan, and right below the two, when they came together, 7.2 earthquake struck. The day that Hurricane Sandy came ashore on the East Coast, the first landfall, the day it came ashore, the same day, a 7.7 earthquake struck out here at the northern side of the Juan de Fuca fracture zone. One more time, up in the northwest here at the Hecate Strait, 7.7 earthquake struck up here. At the same time, a hurricane was coming ashore over here on the East Coast. Many people said it wasn't related. I said, look, man, one side of the plate and the other, and they called it Frankenstorm, by the way. You know, Frankenstein brought alive with electricity. So Frankenstorm dropped all that electrical discharge into the plate, and it went across the plate almost instantly. And we had a 7.7 earthquake strike the same day with a tsunami. But the media was covering the hurricane and barely even covered the 7.7 earthquake and tsunami that happened up here back in, what was that, 2011? Or was it 2012? Anyway, there it is now. We have a threat because the plate is shifting. The more the plate shifts, the more threat it builds. What warning should we put out for the rest of the entire planet? Well, now that a new big earthquake has struck here in the middle of our open area that I warned, you can go watch I don't mean to ham on that too hard, but that we warned this area right here at the Solomon Islands, and a new mid-range 6 came rolling in. Now we have to look to the halfway points between these sets of quakes. And there's several, but I would look downstream. Indonesia's about ready to get hit, as well as Philippines, Guam, up here in between the 4 sets of rings in Japan, coast of Japan, Honshu. That's about to get hit, and it's all about to get hit by something that's larger on both sides. So for Indonesia, I would put it at a mid-range 6. For North Philippines, I would also put it at somewhere in a low to mid-range 6. I would look for an upper 5, 5.9 to near 6, but let's just put it at upper 5, about the same size as over in Philippines at Guam. And then for it to re-pool back up on the coast of Japan with a new low 6. So that should all happen very soon as well. I mean, we're really dealing with a lot of movement. Christchurch did not get hit yet. I think the warning expired last night, going into this morning. I was looking for a 5 to strike between Christchurch and Wellington at Kaikoura, and instead like a 3-something hit, 3.9. That's a full magnitude under what I was looking for. So it might just be a strikeout for me there, but 1 magnitude under hit, right at the spot where I was looking, right on Kaikoura, right here on the red line. But a magnitude under means there's still trapped energy. So where do we watch? In New Zealand, we watch between where the 3.9 came in and the earthquakes up to the north, which means now north tip of New Zealand at the Catcher's Mitt. East of Auckland, this is the Bay of Plenty. You have White Island volcano in the middle. Look right here on the east side of the thumb of the Catcher's Mitt. It looks like a Catcher's Mitt. And I would look for something bigger than that 5 then, since it didn't strike fully. We're missing a magnitude in there somewhere. And man, you got a big push coming in from the north. Looking at it on the USGS plate boundary map, it should be pretty easy to understand. Big push coming in from under here. You just got an earthquake down here, 3.9. We watch at the halfway point between here and here, which puts us right up here. Okie dokie. Ah, yes. Love doing this. So back to the earthquake plan thing. Got the truck packed. I'm here on the screen here just for you to see, just for a few. Hey, by the way, look at that. How do you like that for a fashion statement? They were available for a day. I'm going to make them available again on my Facebook page tonight. Okay, so we'll make that active again. It's not exactly the best graphic of it, but I mean, it's the only way you can get it onto a... This is real. That is a shot from College of DuPage, the first beam that the Department of Defense came back and confirmed me on. If you don't know about the first beam, in the fires out in California, a sudden beam showed up on infrared. Thermal, it showed up. And it showed up as really wide, like a mile or two wide. But the center of it, maybe just a few dozen feet across. And it was beaming down into one of the fires on the West Coast. And wherever the beam went, that's where the fire spread to. The fire followed the beam as the beam went along. I made a video, showed everybody. And below the video, I put in the description, I said, please send this to the Department of Defense. I think I may have just caught something on weather system that's unintended to be seen on a weather system. The video got like 100,000 views the first night. Tens of thousands of my viewers sent it to the Department of Defense. Something like 5 days later or less, it went on for 2 days. Then there was a blip that happened and the thing went away. A blip happened next to it, some kind of explosion maybe or whatever. Well, 2 days after that, 5 days later after my first video, after my viewers sent to the Department of Defense, the Department of Defense came out and confirmed directed energy weapons on satellites in space, and they said keywords like fires at a distance, killer satellites, directed energy weapons. That's Mark Esper, the Department of Defense director, put that out. And that was a direct response. Everybody said it. Direct response to my video going pretty much viral, showing the directed energy weapons beaming down into the fires. Well, that then went on for a little while, a week. We saw it in different spots, different fires, different beams. People said it was a mistake. But then the beam showed up this week, beaming down into the New Madrid seismic zone. And I made another video, and I said, look at this. Then the hotspots flaring up at the same time at the New Madrid seismic zone. Then the earthquake swarm broke out at the New Madrid seismic zone. This is just like what happened on the West Coast. Beams, hotspots, fires, earthquakes. Now we know from Lieutenant Colonel Thomas Bearden, who put out the Soviet Weather Engineering over North America video, which I urge you all to go buy a copy of while you still can. But in his full presentation in 1985, explained how directed energy weapons, DEW, in a beam can convert from radio waves, which are thermal, like microwave basically, and can convert back from radio wave into electrical and go into the ground, the Earth's magnetic field absorbing some of that and taking it to ground as an electrical discharge of millions of watts of energy pumped down into the ground electromagnetically. Turns into what's called piezoelectric energy. And it gets stored in the ground like a battery or a capacitor, better description. A capacitor is like a battery. It stores energy, but shoots it all out at once. And as the crust gets to an inundation point, this is according to Lieutenant Colonel Thomas Bearden, the directed energy weapon can precipitate an earthquake. And specifically using VLF, which is an entirely different type of directed energy. But high-powered microwaves and high-power energy weapons can also convert in what's called efficiency scaling. HARP experiments at the High Frequency Active Auroral Research Program, using high frequency, beaming up into the atmosphere. That high frequency creates VLF, a vibration like a bass drum up in the upper atmosphere, from glowing plasma in a ball up in the upper ionosphere. And that glowing ball of plasma, zapped up by HARP, for instance, just HARP is an example, there's so many others, zapped up into a vibrating ball in the upper ionosphere that resonates out very low frequency in a big multi-kilometer wide glowing plasma ball. And pulsing it with high frequency, they then vibrate it and it puts out low frequency, and they can turn it at a dish like at an angle using what's called an ionospheric mirror and reflect it. And what they found is that when it's vibrating and they can reflect the VLF, reflecting VLF, think about that, reflecting VLF and high frequency, they can inject it into the Earth's magnetic bands of the entire Earth now and ride those bands all the way around the Earth by vibration, and that VLF will follow the magnetic bands of the Earth. And guess what they found? They were able, up here in Alaska to create a ball of plasma over Alaska that vibrated VLF, that rode the electromagnetic fields of Earth all the way down off the southeast coast of Australia, or of New Zealand, where they placed what was called a VLF buoy. And I'm getting to a point on all this. VLF buoy, New Zealand HAARP. Let's see if that brings it up. There it is. Here, online Wiley Library. We should be able to get it from Stanford directly. Here, maybe I need to add Stanford on there so we can get it from the official stores. Well, look who comes up. Tattoo. That's funny. Oh, here we go. ELF observations using at... There we go. This is the National Science Foundation Awards. They awarded the grant to go down and do this, to place the buoy off the East Coast. The ship for the ship distance, 300-kilometer long conjugate area. They call these points a conjugate point. Let me see if I can find some graphics on this. There it is. This is from them now. This is from Stanford themselves. The HAARP one-hop buoy experiment. There we go. Let's get that. Just need the name on it. There it is. Stanford itself. vlf.stanford.edu. And here's the location they broadcast from. Hopefully you guys can see all this. This is the location they broadcast from, up at HAARP in Alaska. And they were pulsing this in a circular formation, scan lines in a circle, which then directed the beam in the opposite direction. And here's their graphic. They were able to inject the waves. Let's see if I can... this is as big as we can get. Oh, maybe I can control plus it a little bit. There we go. The ball of plasma here vibrating injected the VLF wave, and they could either keep it in low Earth orbit and go to a satellite by bending it onto one magnetic band, or send it all the way around down to the conjugate point off the southeast coast of New Zealand. And so they placed a buoy down there off the southeast coast. There's the team. There's the buoy. And they placed the buoy, and this is a VLF antenna up in Alaska. They placed the buoy there, and what they found... Oh, wait, let's get back to their graphic. Is that the VLF from here would go up, around, and come back down, and it would go to the conjugate point, to the buoy, and even go further than that, and go down into the crust, and bounce back. But when it bounced back, it had lost some of the power, the electrical discharge, a lot less power, and it was absorbed by the crust. And they found that the AC, the alternating current of the radio wave, converted naturally as it came down below sea level, because they had this thing tethered to the sea floor, and that it converted to DC, from AC to DC, into the crust. Direct current. Like, theoretically, I guess you could, at the point, like, plug something into the ground or something, like a Tesla light bulb, you know. That's sci-fi, but... So you also see these small little arrows here. You see that? They're right going up to the ionosphere, to the upper atmosphere. It's marked in green. That green line is the atmosphere. So they found also that they can send up another signal. While they're creating the ball, they can take another transmitter, like a radar or anything, any radio wave, and shoot it up at an angle where it then reflects off the underside of the ball of plasma, like a mirror. And it comes back down to Earth, where they can have another dish that reflects it up, and they can create another ball of plasma and reflect it over the horizon, all the way around the planet, inside the atmosphere and ionosphere. Or they can go around the Earth, and in this case, to the conjugate point on the opposite side of the planet. Now, wait a second. Electromagnetic conjugate points on the other side of the planet, what does that have to do with anything? We get back over here, the directed energy weapons. A high-power microwave directed energy weapon could show up on... People thought it was a laser. I'm like, no. Electromagnetic spectrum, the top search. Let's get just a diagram, random diagram here. Let's click on one. Here's one. So, here are our radio waves, like you're listening to in your car. Here's a microwave. High power microwave you might use in your kitchen, or of course you're going to use a microwave to transmit across a distance. Radar is a microwave. Then we go up into infrared. That's where the beam started to be viewed. Infrared up into viewable, visible. Low end started to show up as a red and a purple, going all the way across the visible spectrum on both sides. So ultraviolet is where we come in on the purple. Infrared is where we come in on the red. The beam started out as red. People started to see it. I think whoever's doing it switched to ultraviolet, which then came in on a purple angle, but it was still infringing in on the visible, which made it visible on the weather satellites, which the weather satellite viewing in infrared bleeds over from infrared into microwave, just like visible bleeds over into infrared and ultraviolet. Just like you can see that black light glow in the ultraviolet, get underneath the black light, makes everything glow. You can see that deep purple. Animals can see a little bit further than that, right? A little bit more into the ultraviolet spectrum up here, right? Some animals. Same with infrared. Some animals can see just a little bit further over into the red. And going here between the two, I think that's where the beam was. So the beam that we saw was between infrared and microwave. And guess what? Microwave Can I spell that right? There we go. Sorry, I didn't mean to cough in your ear. Investigation of the electromagnetic microwaves absorption of piezoelectric properties of electrospun nanocomposites. Nanomaterials are they're studying to absorb microwave energy, basically to convert into use. And so a piezoelectric thin film will vibrate and store energy, just like a piece of rock will, but they can use it, in this case, to be excited by microwaves, which then can be converted immediately into power. So in other words, Tesla's wireless power. But what I'm getting at about this is that energy can convert into seismic. And then we get into the earthquakes next to the hotspot locations, and the hotspots next to the beam locations. And the beam locations reflected on my shirt, seen here, which I will make available for another day. That's a heck of a story. Directed energy weapon. And my whole discoveries go back to 2011 with HAARP rings and radars pulsing an entirely different story of weather modification that most people don't even know. I'm going to save this as a magnum opus video, and we will upload this over on YouTube, where we will play it back in a premiere. What do you say, in like 30 minutes? We'll play this all back, and you can watch it back. I guess sip my orange juice. They're not a sponsor. You didn't see the label? All right, guys. I'll be back. Peace out. Much love. Oh, and if anything big hits, if an earthquake hits here in the Midwest, I don't think I'll have power or internet to get an update out. So if that happens, you won't be hearing from me for a while. But if it happens anywhere else, I'll be back on at a moment's notice.